Is that an open circle at 14 or closed?
Closed.
Closed.
Thanks.
No problem.
Thanks, Art, because it
No
kind of looked like that. And when it's right here, kind of sloppy. That's a semicircle. So make a note that this is made up of straight line segments and a semicircle. That would have to be told to you, because when you look at that, you know, even if it's made with software, you'd have to be told like this right here is a semicircle. And this got down to -4. That's a semicircle. What's the area of the circle again?
5 square.
Pi squared. Okay, good. This is velocity. This is about velocity of a bug. Right here, this represents the velocity of a bug. It's just traveling up and down a vertical wire. Right? Now, when you see this, when it's above this x-axis here, right? This is t. The bug's traveling upward. And when it's below, it's traveling what? Downward. Cool? Everyone got that? So this bug could go up, go down, going up, and here's the first thing. We gotta find,
Displacement and distance.
yeah, and I think I'll ask that, like, in a later question, I'm gonna put that down, about the distance and velocity or displacement, words like that. Well, the first thing we're gonna find out is the integral from 0 to 14 of v of t dt. The equations aren't given, but we can see that's a straight line, and when that's a semicircle, and that's a straight line. Well, doesn't this deal with area? So we'll start out and we could say, all right, to get this integral, find that area of that triangle. True? Find the area of that triangle. Then we gotta get the area of this semicircle. And we add stuff together, but of the three areas, which are we gonna assign a negative value to?
The circle.
Yep, the semicircle, because it went below the x-axis. That's what happens with integrals, right? That's what happens with integrals, we know that. So here we go. Let's start with getting this area of this part. All right, what's area of a triangle?
Half base into
Half
height.
base height, right? Okay, so half 4 times 8.
32.
Half 32? 16? All right, so in here we're getting area 16. All right, that tiny triangle at the end. And I did my best there, Cal. It looks like a height of 2, right?
2, yeah.
It's a height of 2. All right, at 2. The width is 2. Half of 2 times 2? 2. We got a 16 plus a 2.
This is half.
Area of a circle is pi r squared. This is half a
So
circle.
half pi r squared.
Love it. Half
Pi r squared.
pi radius squared. The radius is
4.
4. Half pi 4 squared. What's that? 8 pi. So when I write this answer, I could say it's 16 plus 2, which is what? 18, subtract d8 pi. Now you can leave your answer like that. Because we know pi is irrational. Unless you want to use 3.1415926 and multiply it in there, but leave it like that. Alright. Here, make this letter A. Or your letter. Letter B. Evaluate this. I should have put evaluate, right? Evaluate. Definite integral. Evaluate. 0 to 14. Boom. The absolute value of d of t. Boom. dt.
This is the displacement, right?
Oh, good. I'm going to ask those questions in C and D. And when we get to C and D, I'm going to ask you the displacement of this bug. And I'm going to ask about the total distance of this bug. All we have to do is look back on A and B.
So
But, oh, go ahead.
wouldn't it be 18 plus 8 pi?
You got it. Tell us about that. You nailed it. What's going on with absolute value functions? What happens to any graph when you put the absolute value of it? It makes any portion underneath it do what?
Positive.
Flip upside down. Let me say it again. What's the absolute value of any function? The graph would just take anything below that x-axis and just what? Flip it up. So if you're thinking about that graph right there, you're like, just a miniature graph, you're like, that graph did what? It went like this, yeah. But this thing went like that, right? And then it had that little piece at the end. So in this case, Belraj, you nailed it. What are we gonna do with all these numbers? It'll be 18 plus 8 pi, right?
Mhm.
That would be this answer. Leave it like that. No units, we'll just leave it like that. Alright, so now, which one of the following, for the earlier ones, finds the displacement of the bug?
The first one.
And then, remember it was a bug, the bug was crawling up and down a vertical wire. That described the velocity of the bug, right? At some point, the bug had a velocity of 0. At some, from time equal to 4 to time equal to 12, the bug had negative velocity, right? Now, if you think about this, what was going on with this bug traveling up and down this vertical wire, it only traveled for 14 seconds. From 0 to 4, the bug was traveling up the wire. And at time equal to 4, the bug stopped, turned around, and the bug went what? Traveled down the wire. And then at 12 seconds, the bug traveled up the wire. Cool? So it did like this. It was like, it went up for 4 seconds, then it went down, then went back up. Which one of these finds the displacement of the bug? That's how far from the original position that bug is. And which one of those other ones, A or B, finds the total distance? The total distance traveled by the bug. Total distance traveled by the bug. And you nailed it. Which one was it, Art, for
A.
displacement?
A.
A. Integrals of the finds displacement. What do you mean by displacement? How far from the original position the bug was. So if you're talking about me, like traveling right to left, if I went like this, and then I went back to here, to the same spot, my displacement is 0. Right? We're trying to find the displacement of the bug. That would be A. So which one's the total distance? So this finds total distance. If we're talking about that this V of t is representing the velocity of the bug, but it could be the velocity of a particle. Right? Total distance would be the integral, the absolute value of that, because what we do is we add up all those parts. We just reflect everything like that. Everyone okay with that? All right. When you do ask these questions, yes, you got to make sure that you give straight lines to the students. If you do any type of curve, then you got to make sure it's like a semicircle or a quarter of a circle or something like that. Something you're familiar with in terms of getting the area, like a triangle, or a square, or a rectangle, or a circle. Cool? Awesome. Hey, eventually we'll spend the bulk of the day in 5.5 on the substitution rule with U subs. You'll like that, but I'm in 5.4, and there's a specific problem I wanted to do, because it's can kind of throw people off, and it's number 29. This is a 5.4. I didn't want this one to stump you. Four plus 6u. All right, I'm gonna use x. They used u, I'll use x. Dx. Actually, it was a definite integral, but I'm gonna make this an indefinite integral. So I actually changed it a little bit. Maybe when we're done, we'll go back and make it a definite integral. But here, would you evaluate the indefinite integral? Okay, doesn't that mean we're going to find the antiderivative?
Mm-hmm.
But it looks bizarre. we see this expression like this, we might think, oh, was it a quotient rule or something like that? Well, that was derivatives. And we gotta use your suggestion from last class, Bill Rash. Do you remember what it was? How do you deal with something like
X
that?
to the power half,
Yeah, just split.
Yes!
split it.
You like split it, split that fraction, right? That's the idea. You like, think of this as 4 over the square root of x separately, plus 6x over the square root of x. Some of you are so awesome, like, you do that in your head, you know how to, simplify that and get everything up in the numerator. Well, I'll take it slow. That's an x to a 1/2 in the denominator, right?
Mhm.
Alright, so I'm just gonna take it slow. That's a 6x to a first over a 6 over an x to the 1/2 in the denominator. So first I do.
Mhm.
Now, in this scenario, don't we just subtract powers?
Exactly.
Alright, what's 1 minus a half?
Half.
A half, good, so this one's just gonna be 6x to the 1/2.
Maybe negative.
Nope, because it was a 1 minus a half. It'd stay positive in the numerator. Hey, Amber, just for a quick example, look at that guy. And you go, oh, I could simplify that to just be, see, it stays positive, doesn't it? Good deal. But Amber, this one is.
That's going to be 4x
So I gotta get that up there, alright, what is it?
minus half.
There you go. So Amber, maybe you were thinking of that one. That's gonna be
Yeah.
negative. That's the one that's gonna have to be a negative exponent. dx.
You have to keep adding that dx.
Yep. And I know you go, gosh, and I might even forget to write it one time. You can correct me. It goes away when we find the antiderivative. It means with respect to x. I think it's important. You'll get in the calc too. You'll have that. Ooh, and then you'll have like this. So it's important you know which variable you're integrating with respect to in regards to this. And then you'll get something like this. Ooh, you get a triple integral. And you want to stay organized, so plus today it becomes important. You'll notice this is important today. But yeah, from time to time you might just go, hey professor, you forgot the dx. Alright, let's do that. Pump it up by 1. What's a negative half plus a 1?
Half.
Alright, look. 4x to a negative 1/2 plus 6x to the 1/2. Antiderivative, you said 4x to the half, then you divide by a half. That looks ugly. What does it mean when you divide a half now?
Multiply by 2.
Good job. A lot of you do it automatically. You're like, if you're going to divide a half in math, you're like, that means, here, multiply a 2. True?
Mhm.
Multiply the reciprocal? Alright, 2 times 4 is just what?
8.
Alright, we got,
Wait, what?
Part of the
Multiply
answer?
by 2? Oh, you're multiplying by the reciprocal.
you nailed it. Plus, alright, you gotta pump this
3 half.
x to the 3 halves.
Divided by 3 halves.
Amber, would you flip that for me? Because
Two
it looks
thirds.
stupid.
Yeah, so it'll be
2/3.
2/3.
2/3? Alright, so I got enough room in here, I think. Look, plus, and I'm just gonna take this off and multiply 2/3 to the 6, right?
Mhm.
And we'll get that out, because it looks weird, right? What do you mean 6 divide 3 halves? It means multiply 2/3 to that 6.
That
Well, that was 8. What's 2 times 6 divide 3?
4.
4. And now, Josephine, it's an indefinite integral. That means we didn't have these lower and upper limits here. You go, what do? You just put a plus.
C.
C. Plus constant. Plus Charlie. And if you want to be cool, you can make that a square root of x. But you can leave it like this. That's fine.
Why did you divide it by 1/2?
So whenever we do, we'll look at a simple example. You and I integrate x squared. We go, oh, the definition is x cubed over 3. See what we're always doing? We're always saying pump this up by 1, then divide by that value.
Oh, so that's that.
That's the antiderivative rule for these, right? These little monomials. And there's these expressions. And you go, oh, well, it's x to the 1/2, you gotta divide by a half. Or this one became x to the 3 halves, you gotta divide by 3 halves. But it's weird when you divide